For decades, Mars has stood as humanity's default destination in the quest to colonize space, a symbol of our unshakable belief that one day we could transform the red planet into a second Earth. But recent discoveries have painted a far more sobering picture. Scientific reports from NASA and other leading institutions confirm Mars' atmosphere is far too thin, just 0.6% of Earth's. It offers no real protection against cosmic radiation or incoming meteorites. Any drop of water on its surface would instantly evaporate or freeze. The dream of terraforming Mars into a habitable world, it's not just distant. It may be fundamentally impossible for thousands of years. Meanwhile, on the other side of the solar system, a surprising contender is taking the spotlight. Titan, Saturn's largest moon, once dismissed as a frozen wasteland, is suddenly capturing the imagination of scientists around the globe. Titan boasts a thick atmosphere, 50% denser than Earth's, providing strong shielding against radiation and space debris. Its surface pressure is ideal. It holds massive reserves of hydrocarbons, with lakes and seas of ethane that offer virtually unlimited energy and raw materials. Most intriguing of all, beneath an icy crust, 50 to 100 kilometers thick, lies a hidden ocean, an environment that NASA experts describe as having potential for extraterrestrial life within our solar system. So what makes Titan such a compelling focus for space exploration? Why are scientists now calling it the top candidate for humanity's future in space? Perhaps even eclipsing the long-held dream of Mars? Let's dive into the scientific truths behind this unexpected shift in the race to colonize the cosmos. What you discover may completely change the way you view our future among the stars. Before Titan ever caught the attention of scientists, Mars was long hailed as the barren red world where humanity might one day extend its civilization into the cosmos. But as science advanced and our understanding of Mars deepened, a stark reality began to emerge. Mars is an unforgiving and brutally hostile world. It starts with the atmosphere, a crucial factor in nurturing and protecting life. On Mars, it is desperately thin, composed of about 95% carbon dioxide. This means the air is unbreathable, and the atmospheric pressure is far too low for humans to survive without full body protection. Worse yet, this fragile atmosphere offers no shield against cosmic or solar radiation, resulting in exposure levels up to 200 times higher than safety thresholds on Earth. Even small meteorites, ones that would burn up harmlessly in Earth's atmosphere, can strike the Martian surface directly, posing a constant threat to any potential colony. Surface pressure at sea level is too low to sustain liquid water in the open air. Any droplet placed on Mars would either instantly evaporate or freeze, depending on the conditions. That's why the images of ancient flow channels on the Martian surface are just fossilized memories of a distant past. not a reflection of its present state. Temperature is another formidable barrier. While Mars does receive sunlight, its thin atmosphere cannot retain heat. This leads to extreme temperature swings between day and night. The average surface temperature is around -63 degrees Celsius, but nighttime lows can plunge to -120 degrees Celsius, cold enough to destabilize metals and electronic systems without serious insulation. Even during the day, temperatures near the equator might peak at 20 degrees Celsius under direct sunlight, but will rapidly drop below freezing the moment the sun sets. And then, there's the dust, fine, pervasive, and dangerous. Mars is blanketed in a layer of dust that contains perchlorate, a toxic compound for humans. When planet-wide dust storms occur, these microscopic particles can remain suspended in the air for weeks or even months. Faced with these brutal realities, some scientists have proposed terraforming, the idea of altering Mars's climate to make it more Earth-like. However, data from NASA and ESA indicate that Mars lacks the carbon dioxide reserves needed to meaningfully raise the atmospheric pressure. Even if all accessible CO2 were released, it would only increase pressure to about 7% of Earth's level. Still far too low to support life without protective suits. Moreover, suggestions of using nuclear weapons to trigger this transformation come with the unacceptable risk of long-term radiation. Undermining the very goal of creating a safe environment. The truth is undeniable. Every element of Mars today resists life. Humans could not survive without bringing nearly every resource from Earth. Water, oxygen, food, construction materials, all of it would need to be transported through space at enormous cost and risk. While Mars is closer and more familiar than Titan, it is best seen as a scientific proving ground, not the ultimate destination for a thriving human civilization. If Mars is seen as a harsh laboratory for life, then Titan opens the door to an entirely different world, more distant, colder, but filled with a promise of life in forms we've never imagined. Located over 1.4 billion kilometers from Earth, orbiting the gas giant Saturn. Titan, Saturn's largest moon, is not a destination that commonly fuels the human imagination. But for scientists, Titan is more than a satellite. It is a distinct world, a place where life might not need sunlight to begin, yet could still emerge in ways completely unknown to us. Titan is the only moon in the solar system with a truly dense atmosphere. According to data from the Cassini mission, the surface pressure on Titan is 1.5 times greater than Earth's, similar to being 15 meters underwater in an ocean. atmosphere is made up of 98.4% nitrogen, much like Earth, with 1.4% methane and trace amounts of hydrogen, ethane, acetylene, and other hydrocarbons. This means humans wouldn't need pressurized suits like on Mars or the Moon, just insulated clothing to keep warm. In a universe where most planets seem to fight against life, Titan presents a strange alliance between physics and biological potential. With a chemically rich weather system, methane and ethane exist as liquids on its surface, forming lakes, rivers, and even rain. First confirmed by the Cassini-Huygens probe in 2004-2005. The amount of liquid hydrocarbons on Titan is estimated to be hundreds of times more than all the oil and gas reserves on Earth combined. Its lakes, rivers, and rainfall are composed of methane, ethane, and propylene, simple hydrocarbons that are extremely useful. These substances could be harvested to produce fuel, plastics, even building materials. On Earth, they are the product of complex petrochemical processes. On Titan, they are part of a natural cycle. This is not a dead planet. It is a functioning chemical ecosystem. That opens up real possibilities for local self-sufficiency in energy and materials. Something Mars simply cannot offer today. Beneath its icy crust lies a massive ocean of liquid water. Estimated to be about 200 kilometers deep, data from the Cassini mission suggests this ocean may span the entire Moon. Remarkably, its temperature ranges from minus 20 degrees Celsius to 0 degrees Celsius. Made possible by internal pressure and antifreeze compounds like ammonia. That pressure is comparable to the deepest parts of Earth's oceans. Places where life exists without sunlight, sustained solely by energy from hydrothermal vents. If life began at the bottom of Earth's oceans, why not on Titan? Titan's thick atmosphere, combined with Saturn's magnetic field, makes it one of the few bodies in the solar system shielded from cosmic radiation. while astronauts on the Moon or Mars would require thick shelters or underground bases. Titan offers a naturally safer environment, its landscapes are surreal. Icy mountains, smooth plains, and dark, frigid lakes of methane paint the image of a strange Earth. Colder and slower. But perhaps most importantly, Titan invites us to imagine a future unconfined by artificial domes and oxygen pipes. With surface pressure that supports human presence, accessible energy, abundant ice, and a real potential for life. Titan is not merely a place where we might survive, it's a place where we could build. A new civilization, a new beginning on a world completely alien yet full of promise. While Mars seems to demand conquest and adaptation through adversity, Titan offers a different invitation to explore and to build upon its unique natural conditions. Perhaps humanity's future isn't about terraforming a planet, but choosing the right place to begin. The race for space colonization is ultimately a comprehensive comparison between two worlds. From survival and resources to the long-term potential for sustaining a human society. Mars has an extremely thin atmosphere at surface level. This forces humans to wear pressurized spacesuits at all times. Even a tiny rupture could be fatal in seconds. A thin atmosphere also means Mars cannot block cosmic radiation or small meteorites. Titan's thick atmosphere, combined with Saturn's immense magnetic field, provides natural shielding from cosmic radiation. Beneath Titan's icy shell may lie an ocean containing more water than all of Earth's combined. By melting the ice, water and oxygen could be extracted through electrolysis. Forming the basic foundation for life and habitation. Titan's atmosphere also contains up to 95% nitrogen, similar to Earth. Making it ideal for plant growth in closed-loop greenhouses or hydroponic systems. On Mars, habitats would need to be buried underground or enclosed within sealed domes. Every square meter of space would be strictly limited by survival factors. The absence of sunlight, outdoor experience, and prolonged isolation increases the risk of stress and depression. As documented in Mars analog missions like the Hawaii Space Exploration Analog and Simulation, Titan, although frigid, allows for the construction of semi-enclosed surface structures that don't require high-pressure domes. Its landscapes feel strangely familiar: lakes, rivers, plains, and icy mountains. Mars once had rivers, oceans, and a warmer climate, evidence confirmed through geological analysis. But today, its surface is lifeless. If any microorganisms exist, they would have to survive deep underground. Shielded from radiation and extreme dryness. So far, no conclusive evidence of present life has been found. Titan, on the other hand, hides an ocean beneath its icy crust that may host life similar to Earth's deep-sea archaea. Microbes that thrive without sunlight, powered only by chemical energy. NASA has stated that Titan is one of the most promising places in the solar system for discovering primitive life. The upcoming Dragonfly mission, scheduled to launch in 2028, will deploy a flying drone to explore Titan's surface. Especially areas showing signs of unusual chemical transformations. That may indicate biological activity. With the rapid advancement of space exploration technology in the 21st century, Titan, Saturn's largest moon, has slowly evolved from a blurry, icy sphere captured by Voyager 1 in 1980 into a serious contender for humanity's future beyond Earth. That vision is becoming clearer than ever, especially following NASA's official announcement and funding of the Dragonfly mission. The first physical exploration of Titan's surface. Dragonfly, scheduled to launch in 2028 and arrive around 2034, is a rotorcraft lander shaped like an octocopter drone. Unlike Mars rovers, it won't drive across the terrain, it will fly from site to site. Thanks to Titan's unique conditions, an atmosphere 1.45 times denser than Earth's and gravity just 1/7 as strong. These factors allow for efficient flight with minimal energy. Dragonfly is designed to make trips up to 8 kilometers at a time. Exploring varied landscapes, sandy plains, hydrocarbon-rich dunes, and especially the Selk crater. where liquid water may once have existed, offering ideal conditions for prebiotic chemistry. The mission goes far beyond simple exploration. Dragonfly carries instruments to analyze surface chemistry. Measure magnetic fields, assess ice depth, detect cosmic rays. And most importantly, search for prebiotic molecules such as amino acids, nucleotides, or signs of biogenic methane. These compounds were indirectly detected by the Cassini-Huygens mission, but never confirmed in situ. A successful Dragonfly mission could pave the way for bolder steps, namely simulated habitation projects currently under development by NASA, ESA, MIT, and the SETI Institute. In these models, Titan habitats will be 3D printed using carbon polymers harvested from the atmosphere and surface. Dome or cube-shaped structures insulated with thick aerogel layers can maintain stable internal temperatures between 18 to 22 degrees Celsius. Even as outside temperatures fall to minus 179 degrees Celsius. The construction material is derived from methane and ethane, readily available on Titan. liquefied and polymerized to form the basis for homes. Pressure modules and storage. The energy system, too, will break from solar dependence. Since sunlight on Titan is only about 1% of that on Earth, instead, methane-oxygen fuel cells will be developed and sustained. Methane will be harvested from the atmosphere or lakes. Oxygen can be produced through electrolysis of Titan's abundant water ice. According to simulations by NASA's Jet Propulsion Laboratory, one ton of ice can yield up to 888 kilograms of oxygen and 112 kilograms of hydrogen. Enough to power basic living modules for weeks. for food, Titan colonies will rely on sealed hydroponic or aeroponic systems. Crops such as kale, soybeans, sweet potatoes, and seaweed are prioritized for their cold resistance and rapid growth. Titan's atmosphere, composed of 98.4% nitrogen, can be adapted to create an ideal environment for plant respiration and photosynthesis. Greenhouse designs will include customized spectrum LED systems. Simulating solar light to support plant development, even under Titan's dim, perpetual twilight. Yet the obstacles are enormous. Titan lies 1.4 billion kilometers from Earth. Nearly 10 times farther than Mars, even using advanced orbital acceleration methods. Transporting people and cargo will take 7 to 8 years. Radio signals require 80 to 90 minutes each way. meaning all activity must rely heavily on autonomous AI systems and on-site decision-making. A forward base on Titan must operate fully self-sufficiently for at least 10 years. NASA's standard for future interplanetary settlements. Despite the scale of these challenges, Titan remains the only place in the solar system, aside from Earth, deemed realistically habitable in the long term. And more than that, Titan holds an unanswered mystery. A hidden subsurface ocean that may contain traces of primitive life. That single possibility transforms Titan from a space station into something far greater. A new scientific and civilizational frontier, waiting for humanity to cross through its gates. Mars may be a destination for explorers, but Titan could be a place for settlers. Not because it's easier to reach, far from it. Titan poses enormous challenges in engineering, logistics, and time. Yet what it offers are the sustainable conditions Mars lacks. An atmosphere capable of shielding humans from radiation, a chemically rich environment that can yield fuel and building materials. Vast reserves of water in the form of ice, and, most critically, long-term environmental stability, the foundation for any enduring civilization. If humanity is serious about building a permanent settlement beyond Earth, not for months or years, but for generations, Titan is the strongest candidate. There are no global dust storms to bury cities, no violent daily temperature swings, no need to live forever beneath the ground. On Titan, we can imagine surface cities, living structures designed for cold, not pressure, powered by resources harvested in a closed-loop system. A place not just for survival, but for complete and dignified human life. This is no longer science fiction. A closer world, like Mars, fraught with risks and compromise? Or a farther, colder, tougher world, Titan, with the potential to sustain life for generations? If you believe humanity's future doesn't belong solely to this small blue planet, then Titan may be the universe's first invitation. A world waiting to be filled with light, with life, and with the first human footprints on its frozen shores.